All right. What is up, everybody? Tom McGurl here with the latest stream. We're going to be learning Rust, but we're going to be doing something a little bit different tonight. If you've been following along, we've been going through the Rust programming language book. But today, before we start chapter 11, which is going to be on running unit tests, we're going to switch it up. Today, we're going to do some exercises, kind of work those muscles that we've been acquiring as we've been going through the book. And the way we're going to do that is using a library called Rustlings, which we'll talk about in just a second. But if you've been following along, or even if you haven't, do not worry. You can always check my YouTube channel. You can just search my name right up above, and you'll be taken to the channel. And we have all of the previous chapters that we've gone through. Just go through the videos. It started back here, chapter 1. We did chapters 1 through 2. We made it all the way through chapter 10. And we'll be continuing probably going forward. There's also a new video up on Rust development using Docker. So it's going to teach you how to spin up a Docker container for all of your Rust development needs. So pretty cool. Check that out. That was just posted yesterday. And there's going to be more of that. Expect a little more of that. We'll be posting some more one-off content as we get going here. As usual, the stream is Tuesdays from 9 p.m. to 11 p.m. If you're here live, you obviously know that. But if you're watching after the fact on YouTube, check us out live, 9 p.m. to 11 p.m. Eastern on Tuesday nights. There's also some other content up here. We have building a live serverless backend API with AWS Lambda. For that, we used Node with TypeScript, backed it with a DynamoDB and a little S3 for some image storage. And then even further back, we did some work on learning React Native and trying out Recoil.js. So check that out. They're all up on YouTube here. You can check it out here. Goes all the way back. That was a 7-part series, a lot of fun. But today is all about Rust, and it's all about Rust exercises. Again, working those muscles that we've been acquiring going through the book. And this is going to keep us up to date. We can continue with the book, which we will do, but this is going to be a really fun adventure and see how far we can get with the knowledge that we currently have from chapters 1 through 10. If you want updates on when I go live, follow me on Twitter. You'll get updates on when I go live. If you want updates on the newest videos, subscribe on YouTube. You'll get those updates when we post the content like this. And then, of course, everything we do here today and every day gets posted up onto my GitHub. So you can check it out here. We have our Learn Rust Live. This is the live series we've been doing. We have the Brewbook Serverless API. That's the API we spun up with AWS Lambda, as well as some other random things and stuff. So check that out. A lot of fun. Today, what we're going to be doing is going through Rustlings. So this is a really cool repo. It's going to allow us to run through some exercise, and it will test each of our changes to the code. And the objective is for each exercise to get the test to pass. So we'll spin that up. It'll run the tests. It'll tell us what's wrong, or we'll have to try to figure out how to fix it. We'll get the test to pass. We'll move on to the next exercise. Periodically, there's also quizzes throughout. So it's going to be a lot of fun. So let's dive in. All right. So first things first, let's close out some of this stuff so we can get rid of our notifications here. All right. So let's go ahead, and I downloaded Rustlings. If you're going to follow along, just follow the getting started. If you're on Mac or Linux, you can just use this command here. If you're on Windows, of course, open up PowerShell and run this as well. So I've already had it installed, and I've opened it up here. So we have our Rustlings. Now, to get this to run, all you have to do is follow the instructions on the site. And basically what we're going to do is run Rustlings watch. That's going to keep the test running in watch mode. And as we get a test to pass, we'll move on to the next test. So let's check it out. Let's start it up. Rustlings watch. All right. So it tells me that the first issue is in this file. So I can alt-click it. Just open it up in the editor here. Oh, there we go. All right, so our goal is to get this to pass. And you can find here, it gives you some clues, right? So cannot find variable X in this scope, not found in the scope. And once we make the change to make this test pass, it'll run the test and we'll get new output. So here, what's going on? Let's walk through. And we'll do that for each one. We'll walk through each one. We'll kind of read it a little bit. We can read the instructions, get it to work, and talk through it a bit. So here we have to make this compile. Hint Rustlings hint variables 1 if we want a hint. If we don't need a hint, we can continue. So I'm just going to go ahead and check it out. So we have a function main and a variable x, although this declaration looks kind of sketchy. I think we need to actually declare this variable. So we'll make that change and we'll save it. And there we go. Successfully ran exercises variables 1. Awesome. Now, it says the code's compiling, we're all good. If we want to move on, all we have to do is remove this comment and it'll move on to the next exercise. And we're going to keep doing that as we go. So that's going to be the process for each of these. So let's move on to the next one. All right, variables 2. So let's go over to variables 2. All right, let's see what's wrong here. So we have x. It's not set to anything, so it's not going to hit either of these conditionals. So we have to make it hit one of these conditionals to make it compile. So we'll start out by setting it to 10, and it should print 10. There we go. Output 10, code's compiling. We'll get rid of this, run through the next one. So these are starting out pretty easy. We'll see if they ramp up. I'm pretty excited. Variables are something we learned early on. So I think what we're going to see is we'll probably be able to make it through the exercises for the stuff that we've learned. And as soon as we come up to the stuff that we haven't learned, we'll stop. And if that's tonight, great. If it's tomorrow, next week, great. And then we'll move on with the book, chapter 11. So here, let's see what's going on here. Variables 3. Compiling of exercise variable 3 failed. Cannot assign twice to a mutable variable x. So here we have a main function. X is defined as immutable, and we're trying to redefine the value of it here and trying to mutate it. So if we want this to work, we'll have to make this a mutable variable. Let's see if that compiles. Awesome. Compiled successfully. We can get rid of this and move on to the next exercise. Woo! Look at us, breezing through it. Breezing through it. We got the Rust skills. I know it's very easy so far, but come on. This is pretty cool. All right, here we go. Borrow of possibly uninitialized variable x, and this is in variables 4. Okay, so we have x declared as an unsigned or assigned 32-bit integer, but we haven't given a value. So all we have to do is probably give it a value. Ah, 32-bit. Oh, there we go. Code is compiling, successfully learning exercises. Awesome. Next. 5. All right, let's see. Mismatched types. Expected a string slice found an integer. And again, this is the notation for a string slice, but it found an integer. So let's see what is going on. Let's walk through the code a bit. So we have number declared as a string slice right here. Again, this is a string slice. If it was a string, we'd have the string : : from, just a string slice here. And we're printing it. And then here we're trying to mutate it and change its value to 3, which can be either an unsigned 32-bit integer or a signed 32-bit integer. Either way, it's an integer. This isn't possible. So what we can do is, if you remember shadowing lets us redeclare a variable and change its type. So we can do that by simply adding in front of this a let. And that now shadows number, changes its type to 3, and there we go. Everything compiles. Spell a number, 3, plus 2 is 5. Awesome. So pretty cool. So you can see the pacing of it. We get a few little exercises, little challenges. It'll ramp up a bit. We'll have some struct work probably. It looks like we got traits, tuples, strings, and some quizzes, which will be fun. All right, variable 6. Let's see what's going on here. Missing type for const item. So we have const number 3, and we're missing the type. So what we'll use is we'll do our type notation here, and we'll say that number is a unsigned 32-bit integer. Come on, easy. Code's compiling, number's 3, variable 6 successful. We can get rid of I'm not done. And the I'm not done is there so that we can modify our code and see what else works. So we can try different ways of doing things. You can try to simplify your code, keep that comment there, and it'll keep running the tests. So if you don't want to wrap it up, just leave that comment there and you can change code. All right. Also, if at any point you break the code after getting it right, it'll just won't be able to compile, and you keep trying until you get it right. It's almost like test-driven development, right? We have our test, it fails, we make our test pass, and we move on. So if you're familiar with TDD, that's kind of like what we're doing here. All right, so the next one is if one. So we're going to be doing conditional. So if one. All right, so complete this function to return the bigger number. Do not use another function call, additional variables, execute Rustlings hint for hints. Okay, let's try to do it. So we don't need to mind this. This is just the tests. We'll take a look at the tests if we get it to compile. So let's see. bigger. We need to compare A to B. So what we can do is if we just want to use an if, we can say if A is greater than B, right? Because we can use this compare function because we know that integers have the trait that allows them to be compared. So, and we learned that in, I believe, chapter 10, last chapter. I mean, we've been doing it, but we really learned why it was possible last chapter. So if A is greater than B, we'll just return A, else we'll return B. And so here we're leaving off the semicolon and leaving off the return because, again, Rust has implicit returns with the last line of execution. And there we go. Code is compiling. Awesome. So let's go ahead and get rid of this. Actually, let's put that back for a second. Let's look at how the tests work. Well, we haven't learned about unit tests yet, but we can kind of get a feel for what they're doing and see how it works. So we have tests. 10 is bigger than 8. So assert equal, it's doing an assertion. 10, it's calling the function bigger and checking that it's bigger than 8. 42 is bigger than 32, and so forth. So it's 2 tests. So that's pretty cool. All right, let's get rid of this. I'm not done. We'll save it. Move on to the next one. If 2. All right, make me compile. Get the bar for fuzz and default to Baz test passing. All right, so let's look at the test and see what it's expecting. But first, let's dive in and see what this function that we've already have written out is doing. So it's a public function. It takes a string slice and returns a string slice. If the string slice passed in fizzish is equal to fizz, it returns foo, else it returns 1. So it's not compiling because it's expecting a string slice and it's not getting a string slice. Now I can modify it to just return a string slice, but that won't make our tests work any better, I hope. It still shouldn't compile. Hopefully the test will fail. Cool. So we got failed tests. It actually does compile, but now we have failed tests. And we can use some hints here. So failures, bar for fuzz. Panicked at assertion failed, left equals right. So the left was test and the right was bar. So it expected bar, but it got tests. So let's look at the test and see what it's expecting, and that'll help us define our function. So foo for fizz. Assert equals fizz if foo. So if fizz is passed, it should return foo. That's handled already. Bar for fuzz. If fuzz is passed, it should return bar. So let's do that. So else if fizzish equals fuzz, will return bar. Fuzz, we will return bar. Save that, and that one should now pass. Maybe missing an else clause. Because we have an else if without an else. So let's see what the other test is expecting. If literally anything else is passed, it should default to Baz. So that's our else statement. So we'll do else. And again, we left off the return, left off the semicolon because it has implicit returns at the end of the function. And there we go. Our tests are passing. Everything's working great. So we can get rid of this and move on to the next one. All right, functions 1. So we're moving on to functions 1. So we breeze through, I'm talking like breezed through variables, right? We got through if, now we're on functions. This is really cool. Very cool way to incrementally introduce things and learn things. And I think it's really helped that we've gone through the book because we can understand what's going on instead of just doing some trial and error, right? I think that's pretty cool. Make me compile, execute Rustlings hint function. So this can't compile because, well, call me is not defined. So let's define call me. Now, we could probably just leave it like that, but what we're going to do is let's have call me return the unit type, and we'll specify that it returns the unit type, which just means it returns nothing. Main signature actually looks like this. Main returns the unit type. Takes nothing, returns the unit type. So let's save that. Let's see if we get it. Bam, working. Let's go. No output because, again, it returned the unit type. Code's compiling. Ditch this and move on. All right. What do we got? What do we got? Next up, functions 2. Make me compile. All right. Let's see. So what do we have here? We have a main function that's calling call me, passing in an integer. Call me takes a number, and there's no return type specified. So that's one thing. So we're going to want to see what this returns. In this case, it doesn't actually return anything. It just prints. So it takes a number for I in 0 to num. So that's a range. It's going to print that number. So here, it doesn't return anything, but we haven't specified the type that callMe takes, right? And so it says here, expected one of colon, and that's because it's expecting the type. We have to specify what this is. So we can say that because we're going from 0 to number, we probably want to go a range from 0 to a positive number, so we'll use an unsigned 32-bit integer for this. And now that we have the type, everything should pass. Awesome. Code's compiling, and you can see call number 1, 2, 3. Awesome. Next one. Functions 3. All right, what do we have here? So in functions 3, we have callMe, takes a number, prints it out, but we're not passing it a number. So let's try passing it the number, I don't know, let's go with 10. There we go. It passes, and look, it prints out, it loops through and prints out every number in that range. And so again, what's happening here is callMe takes an unsigned 32-bit integer, it creates a range. That's what this is doing here. So it's creating a range from 0 to 10, and it's printing each of those numbers plus 1. So it's not printing out 0 because it's printing out 1. And you can see that it makes its way through the list. Awesome. All right. Next one. Let's get rid of this. Functions 4. Expected type found curly bracket opening. So it's missing the return type. So let's see what this thing returns. So we have a function let original price equal 51, and we're passing that to sale price, and sale price should return, because we're subtracting 10, it's possible to go negative, but that doesn't matter. What we're going to do is return an unsigned 32-bit integer, because we're accepting an unsigned 32-bit integer. Awesome. So let's see what the code does. So sale price takes an unsigned or assigned 32-bit integer, returns a signed 32-bit integer. It first checks is even by calling this function is even. Is even takes the signed 32-bit integer and returns a Boolean, true or false, whether or not it's even. And the way it does that, it uses the modulus. So it says, what is the remainder of num divided by 2? If it's 0, meaning it's even, then return true. And if it's true, it'll minus 10. If not, it'll minus 3. And there we go. We're compiling. Sale price is 48. Awesome. All right. Next one. What are we on? Functions 5. Functions 5. Breezing through functions. Breezing through. This is what we're Rustations now, almost. I mean, we went through 10 chapters of that book. Come on. We still have 11 chapters left, if anyone's keeping count on the book. So we're far from done, although I think we've learned a lot of the basics. All right, so let's see. What are we dealing with here? Let answer equal square 3, and then it's just going to print the answer. So what is square 3 doing? Well, square 3 takes a unsigned 32-bit integer and returns an unsigned 32-bit integer. However, it's saying that it's returning the unit type. So my cursor is actually showing why. Remember that Rust has implicit returns, but to get them, we have to leave off the semicolon and leave off the return statement. So there's two ways to fix this. One way is to add return, and you'll see this will compile. Yep, so this compiles, but if we want to, and this is the benefit of having this I'm not done yet, because it lets us experiment, right? If we want to do the implicit return, which is the more common way to do this, we just take off the semicolon, right? So it's the difference between a statement and an expression. So now we have an expression. And we're done. Awesome. All right, let's get rid of this. On the next one, we're done. Variables, done. Functions, done. If, done. What are we at now? Quiz 1. Who's ready for the quiz? Also, feel free, if you have any questions in the chat or want me to dive in any more into the code here or go into any of the specifics, and let me know. Happy to do so. But we're moving on. We're moving on to quiz 1. All right, quiz 1. This is a quiz for the following sections: variables and functions. Mary is buying apples. One apple usually costs 2 Rust bucks. That's not real currency. Come on, they made that up, right? Rust bucks. It's pretty cool. But if you buy more than 40 at once, each apple only costs 1. So we're basically shopping at Costco, right? Like, so if you've ever been to Costco, you walk in, you buy way more pickles or paper towels than you need. Maybe not if you're stocking up, if you're stocking up, power to you. But you buy a lot more stuff, you get a discount. So we're doing that here. This Apple store is selling apples, not computers, just probably the fruit. I think we're just talking about the fruit. It costs $2 If you buy more than 40, you buy bulk, they give you that discount. They're going to give you it for 1 each. So we're definitely buying more than 40. You can't save unless you spend. I learned that from my buddy Clam Watson during every Steam sale. Shout out to Clam Watson. So we're going to write a function that calculates the price of an order of apples given the order amount. No hints this time. No hints. We need the hints. Clam Watson in the chat. Gotta spend money to save money. This is, yes. My wife says the same thing when she goes to Home Goods, so that makes sense. All right, so we're going to write a function here. So we need to write a function that calculates the price of an order of apples given the order amount. Remember, less than 40, $2. More than 40, $1 each. More than 40, not 40, more than 40. All right, so let's write it out. Let's first see what we have templated here. We have a test. Price 1, calculate the price of 35 apples. Price 2, calculate the price of 65 apples. So they're asserting that price 1 should be $70 and price 2 should be 65. Look at this. Look at the savings. Just look at the savings. You can buy you buy 35 apples, right? You're going to pay 65. You're going to pay $70. That's crazy. You're actually losing money. You should buy 65 apples. Right? Look at this. Crazy. What a gimmick. All right, so let's put our function here. So let's comment this out. So our function, let's look at what we're going to have to include here. So our function is going to need to accept an unsigned 32-bit integer. We're not dealing with negative apples. You can't buy negative apples at this store. You can't walk in there like Sacha Baron Cohen dressed up as Borat and try to buy negative apples. Let me have a -3. Not going to happen. We're going to buy a positive amount of apples because we're positivity. And we got to call the function calculate apple price. It's going to take number, we can just call it num apples. And it's going to be an unsigned 32-bit integer. And we're going to return an unsigned 32-bit integer. And now we need to write the function. So if num apples is greater than 40, remember greater than 40, well, we're just going to return the number of apples because they're $1 each. Else, we're going to return num apples times 2 for $2 each. All right, let's try it out. Failed. Expected type found 32. I was about to say failed. Come on. All right, so there you go. Successfully tested exercises quiz 1. Excuse me. Code is compiling and the tests pass. Awesome. Quiz 1, easy peasy. We're done. Get out of here. Awesome. Very good. All right. Next, we're on to primitive types 1. All right, let's check that out. So primitive types 1. Here we go. Primitive types 1. So let's see. Fill in the rest of the line that has code missing. No hints. There's no tricks. Just get used to typing these. Okay, so we're not dealing with any kind of tricks here. We're just getting used to typing. So we'll just do is morning equals false. So let me just read through this so we know what's going on. We have let is morning equal true. If it's morning, it's going to print good morning. We have is evening. If it's evening, we're going to print good evening. So I'm just going to set is morning. We need to set is evening. So we need a variable called is evening because we're trying to use that. And we're going to say it's evening now. And let's see. There we go. All done. So easy. So again, they're not trying to trick us. They just want us to get used to typing these things. I respect it. Definitely. Because, you have to get used to typing stuff. And I'm definitely one of those learners where if I don't type it and I don't use it and I don't get that muscle memory with writing a programming language, I quickly forget it. It's happened to me with Elm. It's happened to me with Elixir when I've hopped off that. It's happened to me with TypeScript. It's definitely happened to me with C. I don't remember C at all. And Java, for that matter. Don't remember those either. So, gotta keep the fingers going. Keep the brain moving, All right, primitives 2. Fill in the rest of the line that has code missing. Again, no hints, no tricks. Just type. So we have let my first initial equal C. If my first initial is alphabetic, print alphabetical. Else, if my first initial is numeric, print numerical. Otherwise, print neither. And so here it just wants us to do another example. So let's do your character equals, and let's get a little funky with it. Let's see if we can do, oh, sorry. So let's see if we can do, I'm going to pull up my emoji thing. Let's see if we can get a lambda. I guess I can't get it with the emoji picker. All right, so let's just do 5. Get a numerical character. So just getting us used to typing characters. And look, I already messed up. Got to have a semicolon. And you can see Rust had a little red squiggly. It was already indicating to us that we needed that. So there we go. We're compiled. We'll go up here to the top, get rid of that, be done with it. All right, primitive types 3. Create an array with at least 100 elements in it, where the question marks are. Execute Rustlings in primitive for hints. Okay, so we have to create an array with at least 100 elements. So what we can do is we can use a range. There we go. I created it with 101. I created a Dalmatians array, the 101 Dalmatians, and it's successful. So that's obviously would have been a pain to type it out, and that's why they asked for 100. They knew you weren't going to go ahead and try to type out 100. So they're definitely hinting at us using a range. So very cool. All right, types 4. Moving on. Get a slice out of an array where the question marks are so that the test passes. All right, so we need a slice. So if we look at the test, slice out of array, let A equal, we have this array from 1 through 5, and we're asserting that nice slice should be 2, 3, 4. So to do that, the way we get a slice is we do A, and then we want to specify that we want from index 1 to index 0, 1, 2, 3, 4, which is exclusive, so we want 5. Because it's inclusive on the first index, exclusive on the second index. We'll go ahead and save that. Let's see if that works. This is a cool one. So the size for values of type integer cannot be known at compile time. And it's telling us here, it doesn't have a size known at compile time. The trait standard marker size is not implemented for integer. All local variables must have a statically known size. So again, we're creating a string slice, so we need to specify that. And now we should compile. But now our tests fail, and that's because we pulled too many values. So we pulled one too many values. 0, 1, 2, 3, 4. So we want to put that there. And we got an out of bounds. Awesome. All right, so we're compiled. We pulled those values out. We made that slice. On to the next one. Primitive types 5. Destructure the cat tuple so that the println will work. All right, so we have a tuple. We're going to destructure it. Let's see how the print is using it. The print is pulling out name and age, so we can pull that out from cat. So to do that, we'll just do name, age. Easy peasy. Compiles. We destructured the tuple successfully. Moving on. All right. On to primitive type 6. So use a tuple index to access the second element of numbers. You can put the expression for the second element where the question marks are. All right, so let's do that. So let's see how it's being used. We have numbers. It's a tuple of 3 numbers here, integers. We want to get the second, and we'll print it. So to get the second, using the index notation, basically all we do is numbers, and then the index, we want, since they're asserting that it's 2, we want the item at index 1. Bam. Compiled. Done. Primitives. Done. Awesome. Structs. Moving on to structs. All right, let's see. Structs 1. So we have color classic struct, color tuple struct, unit struct, and the tests. So address all it do is make the test pass. So let's check out the tests. What is this? Whoa, look at that. We can run the test right in line. That's super cool. That's awesome. Okay, let's look at our test though. Classic C-Structs. To do, instantiate a classic C-Struct. So that's this here. Such that we can use it in this way. It should have a name. That should be a string slice. And a hex. That should be a string slice. So let's create that. So again, it needs a name and a hex. So we'll do name, and it's going to be a string slice, because remember, if it was a regular string, instead of green, we would be using this, right? But we're not. We're just using that. So we'll make it a string slice. And the other one was hex. Make that a string slice as well. And we'll create a color struct. Classic color struct. And this is the syntax for that. And the name is going to be green. And the hex is going to be hash 0 for R. So the red is 0, the green is max, and the blue is 0. And let's test it out. Oh, I need to probably stop this really quick and restart it. Press any key to close it. There we go. Okay, so we got the first one. Now we have to get this next one. So the next one is expecting a tuple struct that should have two things in it. The first one being the name, the second one being the hex value. So what we can do here in our tuple struct is we need to specify it. And so what we'll do is we'll say the first one is a string and the second one is a string. That's our tuple struct. And they're not named, right? Because it's just a tuple. And so here we'll create green and we'll say green is green. And we'll just copy this here. Semicolon. And now that's passing. Awesome. And now we have another one here we have to figure out. Oh, wait. Expected named lifetime parameter. Missing lifetime parameter. That's because... Let's see. Did it say that about our classic struct? Ah, expected named lifetime parameter. So let's see if we can do, what we can do here is we can use a string. So we don't have to declare lifetime. And now here we'll need to change this to be, and we talked about this a second ago, string from green, string from, and this is going to create the string capital S type. Okay, so we're good there. Now we just need to fix it for our tuple here. And so we'll do string, and we're not changing the test. We're not changing the assertions. We don't want to do that, right? We're just changing what we're putting into them. So here we're just going to do string from, and same thing here, string from, all right, there we go. Now we just have to deal with the unit struct. So the unit struct, which we talked about, is just the single unit. And in this case, they are expecting, when we format the unit struct, for it to print out unit structs are fun. So if you see here, the templating already has the S. So we just need our unit struct to be called, well, unit struct. And so here's our unit struct. So we're just going to do let unit struct equal unit struct. And it's just a structure whose name represents itself, right? And there we go. All the tests pass. We did it. Structs 1, no problem. All right, let's save that and move on to structs 2. So pretty cool. This Rustlings is really fun. I'm enjoying it. I hope you're all enjoying it. I know we're not doing the book today, but we'll get back to it. Don't worry. I just figured this was a good way before we dive into writing unit tests to see what it's like to work with tests and flex those muscles. Chapter 1 through 10, we had an accomplishment. We should celebrate it, right? All right, so structs 2, address all the to-dos to make the tests pass. Okay, so let's see. What are our to-dos? So let me just look this over. So we have a struct called order. We have the debug, so we can use the brackets when we format it, so that's cool. Create order template, which is a function that returns an order. It's a creator for this, and so it creates a template by default with name, year, made by phone, made by mobile, made by email, item count, item number, count. So it covers all of these properties. And we have our tests. Your order. So to do, create your own order using the update syntax and the template above. Okay, so we have a blank order here called order template, and that comes as it's a result of calling create order, which returns an order. So we get this by default. This is the default order. So this order here is what order template is. But we need to create our own new order and modify some stuff. So you can see our name needs to be hacker in Rust, which by default it's Bob. So that's not going to work. And everything else, this stays the same, this stays the same, but our count, instead of being 0, needs to be 1. So we're going to, instead of creating it from scratch, we're going to use the update syntax. And so you may or may not remember what that looks like, but if you're familiar with JavaScript, you've seen something similar, which is the spread annotation. And we're going to do something just like that. So what we're going to do is we're going to change the name first. So we're going to set our name equal to string from hacker in Rust, because name is a string. Great. Oh, and by the way, we have to say that this is of type order. And that's why it was complaining. Next, we need our count to be 1. And then for the rest, we just want everything that's in the default template. So we'll just call this, instead of using order template, we'll just create one. And we'll make it an expression. It's telling us right here what to do. Remove this comma. Okay, so I'll remove that comma. There we go, compiling. So let's look at what we did here again really quick. I'm just gonna make this go away. So what we did was we leveraged the create order template to create this order from scratch. And we pulled in all the properties from that order. And then we overwrote 2 of them. And you may say, well, how did that overwrite them? Because you wrote the properties in front and not after like we would in JavaScript. But in Rust, it's going to take whatever you've defined here, use that, and then use all the other properties from here. So this is okay to write it like this. We could also write it in the other way, and we'll see that that also will work. So if we just do this, I believe it will work. Let's see if it complains. So no, so we can't do it in that order. So we did it in the correct order the first time. So we have to end with this. And because it can't have a comma at the end for whatever reason. Probably because it's not a key value pair. So pretty cool. So what we did was we described our name, we described our count, and we let everything else come from the default order that we're getting from calling the create order template. And we're all good. All our tests pass. All right, what's next? What's next? Let's remove the I am not done. Structs 3. Here we go. Method not found in package. Okay, so let's take a look. Structs contain more than simply some data. They can also have logic. In this exercise, we had defined the package struct, and we want to test some logic attached to it. Make the code compile and the test pass. If you have issues, execute the hint. So right now it's telling us that this is international methods not found on package. There's a few other things. So let's look at our to-dos and see what we need to do here. So we have our struct package. It has a sender country and a recipient country and the weight of the package in grams. Okay, then we have an implementation block. The implementation we have here is we're creating a new, and we're passing it a sender country string, recipient country string, and the weight in grams. And we create a new package. Something goes here. So if there's weight less than 0, so if it weighs nothing, that's probably an issue. So let's look and see what our tests expect. Well, before we do that, let's look at what else we have. Is international, something goes here. Get fees, something goes here. So let's see what our tests say, and we'll try to make them pass. Okay, fail creating weightless package. Let sender country equal string from Spain, recipient country equal string from Australia, and then package new sender country, recipient country, and it's passing a negative. And you can see this here should panic. So that's telling me that it's expecting this test to panic. So what we're going to do is if we have an empty or a weight of less than 0, which is impossible, we're going to panic. And we'll just say invalid weight. All right, let's see if we got that part. Cool. So it looks like we still have some errors, but I think that one should pass. Okay, next test is asking create international package. Sender country, Spain. Recipient country, Russia. So different countries, so hence international. Creates a new package with a proper weight, and it asserts that the package is international, and it calls this function. So it should be true because this is international. So we need to write our function here. And because it needs to return true or false, we're going to have a return type of bool. And what we're going to do here is we're going to say, we're going to just return if self dot recipient country does not equal self dot sender country. We'll leave off the semicolon, leave off the return statement, and use that implicit return. And now we have a function that returns a Boolean if it is in fact international. If this looks funny, it's because I have ligatures enabled, so that's why it's actually going to convert that exclamation point equal to this ligature. It's just a font feature. You can enable that as well. Patatas, good luck with Rustlings. Try not to cheat too much by changing things not in the to-do. Sadly, I can't say because my internet can't handle it. No worries, Patatas. Thank you for stopping by. You can always check it out on YouTube, but appreciate you stopping by. So let's see. The next one is calculate transport fees. Sender country, Spain, Spain. Cents in grams. Package, new, sender country. Okay, so we're creating a new package with the weight of 1,500 grams. And we want to assert that the fees are 4,500. So 2 times 1,500, right? 3,000. Add another 1,500, we're at 4,500. So that means that the price is 3 cents per gram. So we need to code that into here. And so we're going to return an signed 32-bit integer. In fact, we can even return an unsigned because we're not going to have a negative, right? So we can return an unsigned to be more specific about it. And cents per gram, we need to multiply it by 3. So, well, actually, in this case, they're saying get fees cents per gram. So we need to say here that it's 3. So we say 3, so we're going to say it's 3, and we're just going to multiply it. So here what we'll do is we'll say, we'll return self dot weight in grams, times cents per gram. Leave off the semicolon, and let's see what happens. Wouldn't fit. So yeah, we need to do this. There we go. It's working. Let's look at what we did. So we created a get fees function that simply multiplied the weight in grams times cents per gram. And that way, when we multiply 3 times 1,500, we'll get 4,500. Does that make sense? We have is international, which just compares the recipient country to the sender country and returns a Boolean. So this, again, this is an expression. So this is going to result in a Boolean, true or false, depending on the evaluation of the statement. So that works perfectly. So we get a little one-liner. We got a little one-liner here. And here we're panicking when it's less than 0. How do we know to panic? Well, the test kind of gave it away. It says here it should panic. So that gave us a clue. And we are all set. So let's get rid of our I'm not done. Move on to the next one. Just breezing through. Blue. All right, let's see. Strings. Are we on strings? Yep. Strings 1. Strings can be confusing sometimes. All right. Make me compile without changing the function signature. Okay, so we can't change the signature, but we need to make this compile. And currently, it's saying expected string because of the return type. Expected struct string, but found a string slice. Try using a conversion method, blue to string. So it's telling us right there what to do. We don't want to change the function signature, but we can change this. So we'll try exactly what they say. We'll leave that off, let it have the implicit return. And just for clarity, this is equivalent to doing this. And we'll see that that still passes. Great. This is just the more common way to do it. We've been doing this way, but from what I've seen, this is pretty common, the toString, and that's what it told us in the hint, so we'll use that one. And we're all set. And that's because, again, without the toString or without the string from, this is a string slice when the expected return is a string capital S type. So let's move on. Strings 2. All right, let's see what we're working with here. Make me compile without changing the function signature. Okay, so again, we can't change the function signature. So let's walk through it. So first we have let word equal string, and it's a capital S string of the word green. If is a color, so it's going to call a function is a color, then we print this is a color I know. If not, this is a color I don't know. So let's look at the is a color word. So that function takes a string slice called attempt and returns a bool. So it takes a string slice, returns a bool, and it does a check. It's returning this expression here, and this expression is using the or, and all it's saying is it green? Is it blue? Is it red? If it's none of these, it will return false. If it's one of them, and it'll check from left to right, it will return true. So we need to get this to return true in this case, or we need to get this to actually compile, right? So here it's saying expected string, slice found a regular string, consider borrowing here. So we have string here, it says try not changing this line, so we'll use the hint, we'll borrow, pass it slice, and let's see what happens. There we go. So that's all it took. So what did we do? We added the ampersand so that we borrow from this capital S string, giving us this type, the string slice, right? And we're all set. Everything passes. So it's cool. So some of the things, some are a little more challenging, some are a little easier with the hints. But what this is teaching you, and it goes back to something I've said a few times and we've learned from the book, is to lean on that compiler. Lean on those error messages. They're going to give you helpful hints. We do have tints. We have green, blue, and red. But they're going to give you helpful hints because that's what they've spent time on. Someone spent their hard time and energy making these error messages amazing and these compiler messages amazing so that we can leverage them. And that's really awesome. So it teaches you how to type stuff. We're learning how to read the code, right? We're reading code, we're reading tests, we're learning how the compiler. So this is like a very cool, I'm enjoying it. I hope you're all enjoying it. I think it's a pretty fun way to learn and actually use the language. The book has been great, reading through it, but this is really nice to actually get our, feet wet a little more. We've done some exercise with the book, but this is really putting the knowledge we learned to the test. It's almost like the midterm for the book is how I'm going to think of it, right? So we're all being quizzed here. It's like the midterm. All right. Make me compile without changing the function signature. Again, can't change the function signature. So try not changing this line. All right. So string green. Oh, wait, do we move on to... No, we finished this. We got to move on to quiz 2. Quiz 2. All right, let's see. This is a quiz for the following section, strings. Okay, here are a bunch of values. Some are strings, capital S, and some are string slices. Your task is to call one of these two functions on each value depending on what you think each value is. That's pretty clever. That is, add either string slice or string before the parentheses on each line, and that'll call the function. If you're right, it'll compile. Very cool. All right. If you have any ideas on what you think it is in the chat, feel free to say it. What we'll do is you can give me the line number and just say capital S string or lowercase str. but I'm going to go down the line. But if you have any clues or you want to try to guess, pop it in the chat. So first, this one's easy. This is a string slice. Why is it a string slice? Well, it's because we don't have the string from and we don't have the toString. So we know that's a string slice. Here we have the toString. So there we know that is a string. String from high, we know that's the other way to define a string. So, well, I'm just going to say that one is a string. Rust is fun. .toOwned. I'm not familiar with this, but I'm thinking since it's saying toOwned, right? It's not borrowed, it's owned. We're going to say that I'm going to say this one is a string. Not holding you to this. I'm not saying you're saying it. I'm saying it. Nice weather.into. This one I don't know. All right, no hints there. Let's take a guess. Let's say we haven't had a string slice in a while. Let's say string slice. All right. Now, format. What is format going to return? I think format is going to return a string. Okay, this is an interesting one. Okay, so string from, so check this part out. String from, this is going to be a string. This is going to be a string slice. And we know that this is taking a slice of the string slice. So I think we're going to have a string slice here. Trim. Trim is going to take a string slice, and I have a feeling it's going to return a string. Happy Monday, toString replace. Okay, so we know that toString is going to convert it to a string, capital S, but what does replace do? Is it going to return a slice? I have a feeling it's going to return a slice. Oop. My shift key is sticky to lowercase. I have a feeling to lowercase is going to take ownership, and I'm going to say it's a string. Let's see, how bad do we do? Not terrible. Let's actually see before we look at that. Let's see if we get the hints now that it compiles. No. All right, let's see what we did wrong here. Let's see what we got wrong. Expected string found string slice. So trim is going to return a string slice. All right, so that's going to be a string slice. And we'd probably just look at the docs, really, if we were doing this, right? We just look at the docs and find out. And replace returns a string. Interesting. Okay, so toString replace is just going to be a regular string. Interesting. And there we go. All right, let's walk through it again. Blue, we know that's a string slice. It just is a plain string slice. We know that toString converts a string slice to a string. We know that string from is the other way to create a standard capital S string. toOwned, remember a string slice is borrowed, so toOwned made me assume that it's going to convert the string slice toOwned, which is a capital S string, so similar to this. Nice weather.into, we didn't know what into returned. Turns out it returned a string slice. String format returned a string. String slice, the reason it's a string slice is because we're taking a capital S string, right? We're putting the borrow in front of it so that we have a string slice, and we're calling a slice or a range on that. So we know we're getting a slice there. What we didn't know is that trim actually returns a string slice. Happy Monday, toString, we know we have a capital S string, and replace actually preserves that. So we have a capital S string, and to lowercase converts this string slice to a capital S string. Now, is this confusing? Maybe. How will we know? How will we know when we're writing our code? Well, that's what the documentation is for. We would pull up the documentation. Obviously, we're not going to do it during quiz 2. Maybe some of you wrote the answers to your math quiz on the inside label of your water bottle during your tests, but we did not do that. Pro move though. All right, so we are compiled and we are moving on through. Pretty cool. All right. What's next? Enums. Woo! All right, so we cruise through variables, primitive types, strings, functions, if, quiz 1, quiz 2, moving on to enums. Enums 1. Make me compile. Execute Rust hint for hints. I am not done. All right, so to do. Here's the to do. Define a few types of messages as used below. All right, so we're dealing with an enum. We need a quit, an echo, a move, and a change color. And they don't take anything, so we're just going to define them right here in line. Again, this is an enum, so we're going to have a quit, echo, move, change color. And we just need commas, and we are golden. There we go. That's it. So just got some practice writing an enum. Next up, enums 2. Enums 2. All right, so with enums 2, let's see. Make me compile. Let's look for the to-do. There's no to-do. Oh, here we go. Define the different variants to use below. So let's see how we're using message. So here's an implementation block. And so it's implementing a call function on message where it just prints itself. It's debugging itself. So that's, again, remember this means that we need to have the debug trait, right? We're able to debug. And we can render this enum because we have that. Remember, if we remove this, we're looking at display, not debug. So here we're doing debug. Okay, so let's see what we got here. So we need move, we need echo, we need change color, and we need quit. And what it's going to do is for message in messages, it's going to call it. So it's going to just print out each of these. So we need to solve this by adding move, echo, change color, and quit. So let's do that up here. So quit doesn't take anything, so it's just quit. Move is going to take an X. That's going to be, we can just say unsigned 32-bit. And a Y, that's unsigned 32-bit. What else? We need echo. Echo is going to take a string. And so again, see move is a struct. There's no parentheses, but here echo takes a string, right? So we're going to just define it like that. Change color contains, we can do I32. We'll just do U32, U32, U32. We could probably even just do U8. Switch it up. All right, so now we've defined change color, echo, move, and quit. And let's save it. Sorry. Quit, variant or associate item not found in message. Quit. 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 Let's see, did I save it? Let's see what it says. Move not found here. Variant not found in message. Move. Well, let's see. We have quit, echo string, message, move. All right, let's see what's going on here. What if I move not found here, variant or associated item not found in message, echo, so can find echo. Let me see really quick. I feel like this, I'm just gonna run this again, just see. It's going to compile everything. I just want to see if it's an issue with the runner. Probably not, right? It's probably a human error. But nah. You know? Can't take this guy's job with a machine, right? I was like, I'm pretty sure I'm right. I'm pretty sure the robot is wrong. Just saying. So there we go. We're right. It tried to disrespect me. I understand it. But yeah, we're good. We have move, echo, and so we define the enum, and it kind of looks funky, but here's what we have here. We have a struct, right? We have echo, which takes a string, change color, which takes unsigned 8-bit integers, and that's okay because we're representing a color, right? And we have quit, which is just a message without anything attached to it. So we are done. Let's remove the I am not done part and move on to Enums 3. All right. Address all the to-dos to make the test pass. To do, implement the message variant types based on their usage below. So we're going to implement message based on the usage down here. So let's take a look at how we're using message. So move this out of the way. All right, so we have message. We have a struct called point. We have a struct called state. Point contains an unsigned 8-bit integer, for x and y to represent the coordinates. State takes a color, which is, that's exactly how we represented a color. 3 unsigned 8-bit integers, a position, which is a point, so it actually takes a struct that takes a struct, and a Boolean for quit. And here's the implementation block for state. So for state, we have change color. Change color is a function that takes self and the color. It borrows self as mutable so that it can modify the color. So that's how we change the color. For quit, it takes the mutable self and sets quit to true. For echo, it borrows self as immutable and just prints some string, right? Move position takes the mutable self and a point and changes the position of self, or in this case, the state, to p, which is a point that's passed in. Process takes the mutable self and a message, and we have a to-do here. Create a match expression to process the different message variants. Awesome. Okay, so what are the different message variants? Well, we'll want to create them here based on their usage down here. We'll use a match, and we'll make this work. Now we need to see what we need to call the message, and we'll find that out in our tests below. So here's our tests. So test match message call. So we create a mutable state, quit set to false, our point's at the origin 0, 0, and our color is black 0, 0, 0. We're going to call state process message. So we need to have a change color message that takes a color. We need to have echo that takes a string. We need to have move that takes a point, and quit that takes nothing. And here you can see we're asserting that these messages are properly processed by our process implementation block. Okay, so what I'm going to do is I'm just going to copy these here. Let's do this. Change color. And we'll put that up here. And this is just a good way to start. And we'll fix it up in a second. Take echo. Copy that up here. We'll take move. And quit was the last one. And so we got to modify this. So change color takes a tuple of unsigned 8-bit integers. Echo takes a string. Point move takes a point. And quit takes nothing. So there we go. We have our defined message here. Let's pull up our tests. Let's save this. And let's see what happens. All right, test failed. That's because we need to create the process function and the match expression to match on our enum. So let's do that now. That'll be fun. Okay, so how do we do it? We use match. What are we matching on? The message, right? And what are the different options? Well, we could have any of these. So I'm just going to copy these, and we'll show you what this looks like. So if you remember, a match expression, oops, sorry about that. Well, not that that really mattered, but. So for the match expression, remember it's going to try to match on each of our values here. So if it matches change color, we're going to have a function, right? It's going to give us that color, that U8, U8, U8. We can give that a name. We can just call that color. And what we'll do is we're going to call change color and pass it that color. If it's echo, it's going to give us a string. We're going to call that string S, and we'll just call echo with S. If it's move, we're going to get a point, which we'll call point, and we're going to call move position, passing it that point. And if it's quit, well, then we're just going to go ahead and call quit. There we go. And let's test it out. Quit. You might have meant to use the available field self.quit. Yes. So we forgot. We have to call self dot for these because they're all implementation functions. So we actually want self dot there, self dot there, self dot there, and self dot there. Not found in scope. Quit. Because it doesn't return anything. It's just quit. All right, so let's see. So we're almost there. We left off, one of the things we left off is these enums, we need to preface them with their proper enum name. So we're not dealing with change color, we're dealing with message : change color, right? So that's a key part here. And we probably can't put this back. Actually, yeah, we should put that back. So let's see. Oh, I guess we don't need that. There we go. Code's compiling. Let's walk through what we did here one more time. So we have our state, which has a bunch of implementation functions. We have change color, which takes the mutable self in a color and changes the color. This quits, this modifies, this just prints S, this modifies the position, and this processes a message. So we wrote this piece out. And here we had the use case. So we called process, they passed it a message, change color with the color, they passed echo a string. And so we needed to first create our enum. So our enum is message, it has a change color type, an echo type, a move point type, and a quit. And here we just match on that. So we use a match expression message. And it's cool because our function, we know we're accepting a message. So we're guaranteed to be getting a message. And when we write the match, if we had we left one of the cases off, like let's say we accidentally forgot to solve for move, well then it's going to tell us pattern move not covered. So really cool. It makes you handle those patterns. And this is really useful. Imagine, and I know we learned about this, but just to go over it again, in case anyone missed the Rust book chapters, imagine you were doing this in JavaScript, right? Or Python. And you made a request to some resource. You make a request in JavaScript and maybe you do async await or whatever you're using promises, you have to have a catch or a check for errors. Now, a lot of times you'll see people forget to write the errors, or they say, oh, I'll go back and write them later. I won't check for the errors for now. I'll just add my then block and assume everything's successful. Then all of a sudden they're in the subway and they lose internet and bam, now they're getting an error because they have an unhandled error message. That can't happen here. If we represent that request as an option or a result is a perfect enum for this. We say a result because it has either a result of some type or, right, an error. It would make us, in our match statement, handle all of those cases. So there's never going to be a time where you're forgetting to handle a particular case. So very cool. We handled all of our cases and we are good to go. All right, enums 3 is done. Let's remove the I am not done portion up top. Do a quick time check. Ooh, 10:10. All right, moving on. Tests 1. Oh, I think we're gonna write some tests. So we're getting a little ahead of the book here. If anyone's counting. We didn't learn this yet, but we're going to go ahead because we've seen it. We've seen it a lot, right? We've seen everything here has been running tests. So we've seen the test syntax here with our assertions. So I think we can figure it out, right? Shouldn't be too bad. Okay, let's see what it says. Tests are important to ensure that your code does what you think it should do. Tests can be run on this file with the following command, Rustlings run test1. This test has a problem with it. Make the test compile. make the test pass, make the test fail, execute Rustlings hint for hints. So let's try making it pass, let's try making it fail, whatever. You can assert. So we'll say assert 5. Boolean expression required. So we'll say assert 5 equals 4. Failed. So we made it fail. Assert 5 does not equal 4. Passed. Let's try assert false. Fails. Assert true. Should pass. Awesome. So that is what an assertion looks like. Let's move on. Tests 2. This test has a problem with it. Make the test compile, make the test pass, make the test fail. All right, so let's take a look at tests 2. Assert equal. So assert equal is different. Instead of returning, it's going to return a Boolean, but instead of taking a Boolean expression, it's going to take 2 values. So we're going to assert equals 5, 4. These should not be equal. And we've seen this. This is the types of assertions we've seen before in our previous Rustlings. So let's assert 5 equals 5. Awesome. So that's assert equal. A little bit different than the standard assert, but pretty cool. Tests 3. This is going to be new to us. This test isn't testing our function. Make it do that in such a way that the test passes. Then write a second test that tests whether we get the result we expect to get when we call is even 5. So it isn't testing our function. Make it do that in such a way that the test passes. Then write a second test that tests whether we get the result we expect to get when we call is even 5. Execute rustling. Hint test 3 for hints. Okay, let's take a look. So we have our is even function. It's a Boolean return. It takes a signed 32-bit integer and just returns whether or not it's even. We've seen this function before. Here's our test. Is true when even. Is false when odd. So assert true equals is even 4. And then here we'll do assert false is even 3. Bam. Easy. So those are assertions. Pretty cool. Nothing we haven't seen before, right? In our other Dozeboy, what is up? Dozeboy in the chat with the sushi dab. Happy to have you here. So there we go. We've learned how to write an assertion. Tested that. Our test passed. And now let's see down here. We're done. Let's move this. Quiz 3. Quiz 3. We're on quiz 3. How many quizzes are there? There's only one more quiz. Ooh. We're making it. Going through. Clam Watts with the poggers. All right. So this is a quiz for the following sections. Tests. This quiz isn't testing our function. Make it do that in such a way that the test passes. Then write a second test that tests that we get the result we expect when we call times 2 with a negative number. No hints. You can do this. Wow. I want to thank Rustlings for believing in me and all the other Rust stations here in the chat. It's been really great to have the support. Appreciate it. All right, we can do this. Let's do it. We have this public function times 2 that takes a signed 32-bit integer and returns a signed 32-bit integer. It's basically just multiplying that thing by 2, right? Here we have a test. Returns twice of positive numbers. So returns numbers times 2. So assert equals 4 times 2 is 8. Duh. Returns twice of negative numbers. So we need to write an assert for that. So we'll just do assert equal times 2 of -4 is also 8. Let's see, do we get it? Failed. What failed? Returns twice of negative numbers. Times 2, -4, 8. Let's see. Here we go. Successes. Returns twice of positive numbers, and this one failed. And you can see the left was -8 and the right was 8. So I'm assuming we have to make this pass. Then write a second test, the test where we get the result we expect when we call times 2 with a negative number. All right, so you should get some lit jams going while you code. Yes, that is a great idea, Doze. I will have to find some license-free jams, and there are some out there, and I've looked into it. That is a great idea. So maybe future streams when we're going through Rustlings or something, we will do that. Otherwise, our videos get taken down, and we do not want that. It's happening a lot right now on Twitch. So, but there is music that is allowed, but it's few and far between, and a lot is changing. So I will wait. Yeah, I'll play Smash Mouth. That'll be worth it. All right. So what's going on here? Times 2, -4. It's returning me -8. That's not what I want, right? Well, we're not squaring, so it's actually correct, right? We're not squaring. I'm just silly. Thought we were squaring for a second. I forgot we're multiplying. So this is what we want. So we're done. -8, 4. We're all good to go. Remove that. We beat quiz 3. We beat quiz 1. We've done variables. We've done primitives. We've done enums. We've done structs. We've done strings. We've done quizzes 1, 2, and 3. Oh man, we got Smash Mouth going on in the chat. Oh jeez. Woo. Ugh. All right, so let's see what's next. Make sausage. Ooh. I feel like Rustlings heard us. They heard the chat, and they gave us a function like this. Okay. All right. So modules 1. Oh, this is awesome because modules I haven't gotten a lot of practice with. We did it, right? We did it with the book. If you followed along with the Rust book series that we did, you were with us for the modules chapter, but we hadn't really used them since we did them there. So I'm excited for this. So let's open up modules 1. Oh, look at this. Look at this cool little, oh, that's pretty cool. Modules 1, make sausage. All right. Make me compile, execute Rustlings hint for hints. So here we have this module sausage factory. Really? Okay. So here we have this module sausage factory and a function called make sausage. And we want to print sausage. And here we are calling it, but maybe we got to make this module public, right? We see right here, private function. It's not within the same scope, so we need to make this public. All right. Oh, I think I did it wrong. No, what did I do wrong? Let's see. Oh, duh. I made this public, but I got to make this public. So remember, if I expose the child, make this public, we can access it. So Trithank, I think I coded all this in college. Yeah, right? Sausage factory. Oh my God. All right, so now we have our public function make sausage, and this all works. We are good to go. Gonna get rid of that. All right, now we are on to modules 2. Modules 2, make me compile. Ooh. All right, so we have to make this compile. Delicious snacks. Ooh, see, I like this better. What do we got? Oh, these aren't snacks. These are fruits and veggies. What? Snacks. The sausage was more of a snack. All right. So delicious snacks. We have use self fruits pair as fruit. Use self veggies cucumber as veggie. So we have pair as fruit, veggie as veggies. Print ln. Favorite snacks, blank and blank. Delicious snacks, fruit. Delicious snacks, veggies. So here we have cannot import fruit as it's private. So we can make this. So here we're calling the use self fruits pair as fruit, veggies cucumber as veggie. So cucumber is the veggie. Here what we're doing is we're calling delicious snacks fruit, delicious snacks veggie. So let's see. Let's try to make some changes and see what happens. We have our constant pair and apple. So let's see what we have to do here. So here I've tried making module fruits public, but let's see what it says. The constant import fruit is defined here. Line 7, right? There it is. And refers to the constant pair, which is defined here on line 9. Or sorry, line 11, column 9. Consider importing it directly. So let's get rid of this. So consider importing it directly. All right, so we got to consider importing it directly. So delicious snacks, fruit, pair. So let's see what happens when we do fruits, pair. Private. So it's saying that this is private module. Fruits. So if we do pub, private const import. So that's for veggie. So if we did veggies, cucumber, all right, module veggies is defined here. Module veggies is private. Make that public. All right, so it's working, but let's walk through it because I think there's a much better way to do this. So here we're dealing with modules, and remember that we need to make them public and we can import them in such a way. But here we're actually saying use self fruits, pair as fruit, use self veggies, cucumber as veggie. And then our main function, we're actually grabbing it directly. So we made it public, and now we're grabbing the thing directly. But I think there actually should be a way to be able to grab it with the shorthand because of that use. And I think the way we want to do that is like this, maybe? Veggie not found in the scope. Okay. So veggie not found in the scope. And in delicious snacks, let's see why it's not letting us do this. Private constant import. Oh, do we have to make this public? I don't know the syntax for this. And we can use a hint after this. Is this a thing? Oh, that's pretty cool. So we just have to make these uses public. So let's go back. Let's go back a bit to the beginning and do the bare minimum here. So let's make these public. Awesome. Okay, so what's happening here? So I get it now because I'm thinking about how the modules worked. So we learned that with modules, as long as we make one of the children public, we can import it we can import it by going into the module. So if I wanted to use fruit directly, like this, so I'm going to comment this out. If I wanted to grab apple, for example, I would do delicious snacks, fruits, apple. However, I can't do that because even though apple's public, fruits is not. So I would have to make fruits public, right? But instead, this module, delicious snacks, it has an exposed apple and it has an exposed carrot on purpose. We're only exposing pear and cucumber. The way that we do that is we use a use. So we're saying, hey, grab fruits pear and let's call it fruit. Grab veggies cucumber, we'll call it veggie, and we'll expose that publicly. And that's how I'm able to then use delicious snacks fruit and delicious snacks veggie in this way here. So pretty cool. And yeah, I'm glad we're getting to use models because obviously we haven't touched it with the book. So pretty nice. Although if I wrote this, I'd probably go with Dunkaroos and maybe, what other good snacks? What are some good snacks, chat? Dunkaroos are great, classic. They brought them back. Even if they didn't bring them back, I'm just going to get a tub of frosting and some Teddy Grahams and make my own. PB Crisps, classic, powerful cane. Those Boys is basically saying lobster. He's saying fried cockroach, essentially what lobster is. Oh man. Yeah, I would say top of my list, definitely PB Crisps, bring those back. Dunkaroos, bring those back. Next, if you really want like a good solid snack, I mean, Pop-Tarts, Famous Amos cookies, Cheez-Its, Chex Mix. That's like what I'm going for. I'm reaching for those. You know, if I'm reaching for something healthy, I'll do like a little pita chips and hummus, Red Hot chips, carrots, kettle cooked chips, jalapeno chips, amazing. Kettle cooked though. They had to be kettle cooked. I do like the non-kettle cooked cheddar ruffles. Bring those to the party. All right, save this. Let's see what the next step is here. Whoa. Collection, vector. Yay, we're on vectors. We learned about these. Sour cream and onion, classic. Actually, give me some Ruffles chips in regular sour cream and onion dip. Just give me the real dip. All right, vector 1. So let's go to vector 1. Where is that? Collections. Vec 1. All right, we learned about vectors. We can handle this. All right, Vec 1. Your task is to create a vector which holds the exact same elements as in the array A. Make me compile, pass the test. Execute the command Rustling hint collections 1 if you need hints. Yo, listen, chat. We haven't used the hints command yet. Hold me to it, right? We haven't used it yet. We're going to try not to use it. If we need it, we'll use it. It's there, but we haven't used it yet, so I'm just saying. No big deal. All right, array to vector. Array to vector is a function that returns an array of length 4 of signed 32-bit integers and a vector of signed 32-bit integers. So it returns a tuple. The first item in the tuple is an array, length 4 of 32-bit integers, and the second item in the tuple is a vector of signed 32-bit integers. So how do we do it? We're going to use our vec macro, and we're going to do this. Bam, done. Now, what I want to do is I want to see if we can actually leverage A here. You know what I'm saying? Let's do, I think we just do A dot dot because we want, let's see, can we do this? What if we did A? Okay, I guess we gotta go with this. Well, it worked. So that's how we create a vector. Dozeboy in the chat says, In my old age, for a snack, I'm going a nice cookie or pastry with some coffee after breakfast. Woo! I like it. That does sound quite delicious. All right, there we go. Test pass. Let's quit this out. On to the next one. Vectors 2. So we have to make the test pass. All right. A vector of even numbers is given. Your task is to complete the loop so that each number in the vector is multiplied by 2. Make me pass the test. Execute the command for hints. Okay, so we have vector loop. It takes a mutable vector v of signed 32-bit integers and returns a vector of signed 32-bit integers. For I in vector intermute, so it's iterating over it in a mutable way. Fill this up so that each element in the vector v is multiplied by 2. At this point, v should be equal to that, and then we return v. Okay, so let's do. We have a mutable v, so we'll do v at I equals v at I times 2. Slice indices are of type usize or ranges of usize. So the indices is a usize, but I need a integer 32. And it says here, help. The trait slice index is not implemented for mutable I32, required because of the requirements on the implementation of index. Okay, so what we can do is we can say as unsigned 32. I think that would do it. Cannot cast mutable integer 32 as unsigned 32. Oh, also, if you notice that it said that we have a mutable reference. So we're using intermute, so we have a mutable reference. Part-time lover. You'll usually see me scarfing down some deviled eggs. Ooh, that's a good one. So we have a mutable reference. So what we can do is we can say as 32, as 32. And then I think we could do this. This seems funky. Let's just see what happens. Let's see what happens. It's probably a better way to do this. As an expression can only be converted between primitive types. Okay, so we can't do that. All right, so let's see. What does intermute do? Well, if we don't want to look it up and we want to try to guess, it's going to mutate over v in an iterable way. We have I, which is a usize, right? I is a usize. And when we save this, it gives us some hints. It says slice indices are of type usi or ranges of usize. So it's saying this is of usize. So the slice indices. So what if we did as u32? Slice index is not implemented for a mutable integer 32. Mutable reference to an integer 32. All right, so let's see. So we're given I. I is of type okay. Iterable mute. Okay. So we can use our hints, but you know what? Yeah, here, let's zoom up a little bit. We got more errors here that we can leverage. Type I32 cannot be indexed by, so the type of array, in this case, 32, that's V, the vector, cannot be indexed by a mutable reference. Same thing here. So it's pointing first here. It's telling us here as well. So those two spots. So we can't do it this way. So how are we going to do it? Well, we can't be indexed by a mutable. What if we did that? Slice indices are type usize, cannot be indexed by an integer 32. Okay, so we don't now no longer have the mutable reference. We actually have the integer 32, but it's saying they cannot be indexed by integer 32. Slice indices are type usize and ranges of usize. So we need to have What if we did all right, first one's good. What if we did it to, so right now what we're doing, I'll go over in a second here. What I'm doing is we had I, when you go over Intermutable, is giving you a mutable reference to a 32-bit integer. I'm dereferencing it, getting the value of it, and I'm casting it to a usize. And here I need to, sorry. So here what I'm doing, let's go over this first part. So what I'm saying is we have our vector v, and I want to grab index I. But now I is a mutable reference to a 32-bit integer, but you can only index vectors using usize. So what I'm doing is I'm dereferencing it, getting the value, casting it to usize, and setting it equal to, I want to get the value out of this, right, and multiply it by 2. So I tried doing the same thing, and now what we have here is type integer 32 cannot be dereferenced. So I probably don't have to do. Okay, so here what it's saying is cannot borrow v as mutable more than once at a time. So we did it here, we did it here. So I wonder if we can do. So it caught on, it knows the deal. So first mutable borrow is here, second mutable borrow is here. So we can't do a mutable borrow. All right, we might have to reach for the hints. I don't know. We might have to reach for the hints. Let's see. Let's try something else. Let's try just modifying v. Let's fill it with 2's. Let's see if it actually works. Oh, so this needs to be as usize. Let's just try filling v's with 2's to see if we can get it to compile. So yeah, so we can't do this because it's a mutable borrow. All right. I respect it. And the mutable borrow is already happening here. Let's look up what Intermute does. I think that's fine. And then we'll go for the hints. Let's see. Because we gotta use the docs. It's fine. Intermute. Mutable slice iterator. This struct is created by the intermute method on slices. So if we have a slice, so this is for slices, we want vector. I guess it's kind of similar. So, I gives us the thing. Sorry, it doesn't give us the index. It gives us the actual item. That's my problem. So silly. See, I'm already forgetting everything I've learned. So what we can do is we get a mutable reference to I, right? We saw that, a mutable reference to the 32-bit integer. So all we need to do is I and multiply it by 2 because it's a mutable reference to I. And we do want to get the value from I. So we get the value from I and multiply it by 2. Or in this case, yeah, we want to multiply it by 2. All right, so here we have left equals 2, 4, 6, 8, 10. So we need to say I equals I times 2. It's a 32-bit integer. So, okay, let's see. So, I is a mutable 32-bit integer. Cannot multiply integer to mutable I32. So that's why I'm going to dereference it. And let's see what it says here. It says mismatch types. Expected mutable 32-bit integer found 32-bit integer. Oh, we need to dereference this. We need to set the value, not the reference. So, a little confusing, but we'll go over it now. Okay, because I was a bit confused. So for I in v intermute is going to return not the index, which is what I was thinking it was doing. It's returning the actual item. Then what we want to do is intermute's returning a mutable version of the item, meaning we can modify it. Now, because it's returning a mutable reference, we don't want to change the reference, we want to change the value. So we first destructure this. Now we're saying the value of I, which is mutable, is equal to the value of I times 2. So that's how it worked. And now what I want to do is an experiment, and I want to see if this shorthand is a thing in Rust, just like it is in JavaScript. Let's see if this is a thing. Yes, it is. So the value of I is equal to itself times 2. We did it. Sorry, that was a little rough. Got a little scared there, not gonna lie. But we did it. Very good. Next one. On to the next one. What time are we at? Almost done here. 15 minutes. So we'll try. I think we can get through all the collections, I hope. Hash maps 1. All right, let's see. A basket of fruits in the form of a hash map needs to be defined. The key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. We have to put at least 3 different types of fruits, apple, banana, mango, in the basket, and the total count of all the fruits should be at least 5. Make me compile and pass the test. Let's go. Let's do this. Fruit basket, hash map. String and an unsigned 32-bit integer. You got to have positive amounts of fruit. We're all about the positivity. No one wants negative fruit. Sometimes it's summer, you bite into that plum, you get a negative experience. We don't want that here today. We want only the best plums, only the most positive. All right, let mute basket. So we have to declare a hash map here. And 2 bananas are already given for you. So it inserts 2 bananas and returns the basket. And in our test, it should have at least 3 types of fruit and at least 5 fruits in total. So let's create our hash map. Let's do banana 4. I totally forgot how to create a hash map. And we did it not too long ago. Hash map. Oh man, it's been too long. I forget how to do it. Who remembers? Let's see. Might have to use a hint. It's been a while. I got to go back to our book. I got to go back to the Rust book. Let's go to our, you know what? Let's do this. Let's leverage our own repo. We got it. We did hash maps, but we didn't put that muscle memory to work, so we forgot, or I forgot. Maybe you remember. Maybe you're in the chat and you're like, what a dum-dum. Pineapple, best fruit. Pineapple's probably one of my favorite fruit, for sure. All right, hash maps. That's in collections. We did this work. We're just using our own work here. It's like looking at your notes, like an open book test. Come on. Hash maps, how do we do it? Hash map new, that's right. We didn't use an inline syntax, we used hash map new. All right, so we used hash map new and then we inserted. Come on. Hash map new, and then we will insert basket, and it's mutable, so that's why we're able to insert. We'll do a string. Let's try it this way. We'll do what do we want? Pineapple dot to string. We know that does that, and we'll do 1 pineapple. We'll insert part-time lover in the chat says, I thought strawberry is your favorite fruit. Yeah, pineapple is one of my favorites. Strawberries and pineapples. Together, they're amazing. Part-time lover said, mutable like your favorite fruit, apparently. Savage. Savage. All right, so basket insert strawberry, because strawberry's so good. Part-time lover is just remembering that amazing beer I had with strawberries, acai, and milk sugar. So good. Let's put, you need a few strawberries. Let's put 4. And that should give us at least 3 different types of fruit. Toasted coconut, that was in there as well. Strawberry, we're going to put at least 4. That should give us 7 in total, and we should be all good to go. Method not found in static string, because we have to bring that in. So, to sting. So we're going to take this, we're going to convert it to sting, which is going to convert it to, obviously, sting from the police. And there we go. We created a new hash map basket, inserted 1 pineapple, 4 strawberries, and 2 bananas. We're going tropical. We're going to make a smoothie. Put a little ice, put it in a blender. We're going to have a nice smoothie from this hash map, and it passes both tests. Let's take a look at the tests. So our tests, we have 2. The first checks that there are at least 3 types of fruit. How does it do that? Well, it looks at the basket length. So we can actually use length on our basket, right? So we can do length on the hash map, and it checks that there's greater than 3 items. Next, it's going to check the values from our hash map. So we're getting a lot of info from these tests. So it's going to check the values and make sure that there's at least 5. How? It's going to call fruit basket to get that basket we created. Then it's going to use .values on that hash map. .sum, integer 32, so it's going to sum the values and return us greater than or equal to 5. So this is pretty cool. I haven't seen this yet. This is pretty awesome. And we can mark ourselves as all done. All right. Hash maps 2. A basket of fruits in the form of a hash map is given. The key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. You have to put more than 11 fruits in the basket. 3 types of fruits, apple 4, mango 2, and lychee 5 are already given in the basket. You're not allowed to insert any more of these fruits. Help me pass the tests. We got enums. Let's go. So we have an enum. Derive hash, partial, equal, equal. So I guess it's allowing us to compare. Fruit basket, it's going to take a mutable hash map where the key is a fruit, which is represented by this enum. The value is a unsigned 32-bit integer, so we're talking about positive 32-bit integers. We got lychee, mango, banana, apple, pineapple. Here's our to-do. For fruit in fruit kinds. To-do, put new fruits if not already present. Note that you are not allowed to put any type of fruit that's already present. So we can't insert fruit that's already present. Let's look here at our tests. So let's see what we're testing for, and that'll give us a better idea of what we're dealing with here. Get fruit basket. So get fruit basket returns a hash map. It's our fruit basket hash map containing a key of fruit and a value of an unsigned 32-bit integer. It creates a mutable basket right here. It inserts apple, mango, and lychee and returns the basket. So this is just going to be used for the test. So this is a function used by the test. The test is going to insert these 3 by default. Okay. Test given fruits are not modified. So it's going to create that fruit basket, and it's going to assert that these fruits aren't touched. So we can't modify these. So we're going to have to put that check in place that these don't get modified. At least 5 types of fruits. Yo, this Rustlings exercise is making a lot of assumptions that we know a lot of different kinds of fruits. Now, we may be sheltered, and we may have only had apples and oranges growing up in the suburbs. But we can come up with 5. We'll do it. At least 5 types of fruits. It creates a basket, right? Fruit basket. Count fruit kinds. It's another function here. So the count of fruit kinds is getting the length of the basket. So it's just getting the keys, the number of fruits. And it's asserting count fruit kinds is equal to 5. So that has to be 5. Greater than 11 fruits. So there needs to be 5 different kinds and greater than 11. And again, it's using that sum to check that it's greater than 11. All right. So I can't modify these. Got to create some new ones. And one thing worth noting, fruit basket takes a basket. So it's being called here, right? Fruit basket takes a basket. So we need to make sure not to modify these. So what we're going to do, we're going to use a match. We're going to use a match. You understand what we're doing here? We're going to use a match on this. Put fruits if not already present. So which ones are already present? Well, whatever is in the basket that's passed in. So in their case, apple, mango, lychee. So we first need to check if the fruit is in the basket. Make sense? Got it. So if fruit in basket, that's not gonna work, is it? So what we're gonna do is we're gonna say check if fruit is already in basket. If it is, just skip it. So if we'll do basket dot, we need a function here. Basket contains fruit. So fruit and fruit kinds is going to give us the kinds of fruit. Try basket insert fruit fruit Tom. Ha ha ha. Good one. There's this function that we can use. It's called insert. We used it before. Let's pull it out. It's like insert if it's not already there. There's actually a function for that. So let's see. Insert or insert. Love it. Scores. So entry or insert. That's what we're going to do. So we're going to do basket, entry, fruit. This is going to give us the number. So we're just going to check its existence. So basket, entry, fruit dot or insert. And we need to insert, again, we want to insert a value at that fruit. So we'll insert, we'll do 5. We need to have more than 11. So what is this doing? For fruit in fruit kinds. So for each of these, it's going to try to grab it or insert it. And now, of course, what it's going to do is we don't want to return anything here. Right? This is going to return the value. So we could say like let current value equal. But we don't care about the current value. So we'll just let it be. We'll execute it as a statement. And we're done. What did I do? A little bit of magic. Let's go over it. We wanted to insert fruit only if it wasn't present. We're given a basket that may or may not already have some fruit present. And what we're doing is we're looping over the types of fruit, which come from this enum. So we first create a vector from this enum. We loop over the types of fruit. And this does a check. This basket.entry will check to see if that is there, right? And so it's going to return an option, right? So we can probably see that here. If I look at, let's look at the docs really quick. So we can do entry, and we can see what the return type is, just to go over it. Rust hash map entry. Okay, entry. So entry returns hash map entry. A view into a single entry in a map, which may either be vacant or occupied. The enum is constructed from the entry method on hash map. So it'll give you the value if it's there. And then what we're doing here with the dot or insert is we're saying if it's not there, right? If it's not there, we're going to insert 5. So it's not going to touch the ones that are there. It's going to insert 5. And the reason we put the semicolon is because this is an expression, right? It would return the entry. It would return the number or 5 after inserting. We don't care about that. So we're just going to make it a statement with the semicolon. And we saved it, and now we're good. It worked. So we successfully did it. No thanks to part-time lover in the chat. No, I'm just kidding. He helped. You helped. Thank you for being here. Always appreciated. Always happy to see friendly faces. All right. Macros. Well, we are pretty close to 11. Let's take a look at how many are in macros. All right, so we're going to save macros. Actually, wait. Yeah, we're going to save macros. We'll stop it there for today. This has been fun. Rustlings is fun. I hope you're all having a good time. I like that we're using stuff. You know, I already forgot how to use hash maps, so it's good. If we don't keep using them, I tend to forget them. That's just how I work. But that's why I decided to do this before hopping into the testing chapter. I think what we'll do, since we haven't really dove into macros, but we have dove into generics, conversions we haven't done yet. We've done generics, so when we get to that, that'll be something we've covered. Haven't really done too much with Clippy. There's only one more quiz, so we don't have much more to go. So I think we'll try to finish this. And then we'll continue with chapter 11 on writing unit tests next Tuesday. So yeah, it should be fun. I've been having fun with Rustlings. I hope you all had fun following along. It's been pretty good. I think it's been a fun chapter for sure. Again, if you missed any of the previous chapters, well, you can find them. They are on my YouTube channel. I also just recently, yesterday, in fact, uploaded a video on running Rust in a Docker container. It's a short, about 15 minutes, right there you can see 14 minutes, 38-second video. Just a short video on how to run Docker for local development. It's going to use a Docker compose file. This way you don't have to have a Docker installed on your machine, and you can have a repeatable environment as long as you have Docker installed, of course. And there's links to do that in the show notes for that. So check that out. Check out any of the other parts in our series for where we went over the Rust book. Again, we've done chapters 1 through 10. You can see them here, part 1 through part 10. That covers part 1 through 10, obviously, chapters 1 through 10. But also we did some exercises in chapter 8, which were really fun. There were a lot of exercises and other exercises throughout. So that's been pretty fun. So subscribe there. You'll get updates when new content comes up. I'm going to be creating more one-off content like that. I had a lot of fun with it. It was fun trying to do some video editing. So it's going to be great. Jeff Veronius. Oh, no, not again. Yes, Jeff Veronius, you joined exactly this time last stream as well where we were doing the end. Don't worry, though. Like last time, it'll be posted, Jeff Veronius, so you can check it out right there on YouTube. And you can watch it faster. You don't have to sit around for 2 hours. You could speed it up. 2x speed, whatever you want. Of course, you miss out a little bit on the live chat, but glad to have you here anyway. So check that out. Jeff Veronius, follow me on Twitter. You'll get the notifications when I go live. I post it. I tweet it. Twitter handle's right up there. If you have Twitter, follow me there or subscribe on YouTube. You'll get those notifications. Follow on Twitch. You'll get those notifications. You can set that up. But yeah, anyway, it's thanks for having you here. We'll continue to Learn Rust Live. We'll finish up Rustlings next time. Rustlings has been really fun. And yeah, check out the GitHub repo. I'll push up my code so you can see it on GitHub. And that's basically it for today. A lot of fun going through Rustlings. Really enjoyed it. Gonna look forward to finishing that up. Looking forward to chapter 11 of the book and continuing with that. I think we're really coming along as our stations. We breezed through that first chapter. We ran into some friction towards the end, right? We ran into a little friction because it was we just have forgotten hash maps, but we got through them all. We didn't use any hints. We did have to look some stuff up, but we looked up either the docs or in our own code. So that was really fun. But again, we just did it as a challenge. Of course, you'll be able to look stuff up. So, and maybe, if we get stuck again on the macros, which we haven't learned yet, we'll try out that hints command. So I'm not too worried about it. Well, thank you everybody who joined the chat. Thank you if you're watching later on YouTube. Thank you for stopping by. Hope you're enjoying the content, and I'll see you all next week. Have a great night.